Our guest today is AWS aerospace and satellite customer Ryan Westerdahl, CEO and founder of Turion Space.
I'm Ryan Westerdahl, the CEO and one of the founders of Turion Space. At Turion, we are building and operating droid satellites, and we aim to unleash the potential of Earth orbit. So I'll get into what that means in a minute, but I'll first tell you a little bit about my story, what really got me into the space industry in the first place. Like a lot in this industry, as a young kid, was just obsessed with space. Specifically learning about planets around other stars and making it my life mission to build the ships that go there. Reality check, it's not going to happen anytime soon. So what's the next best thing? Probably got to go to Mars. Who's doing that? SpaceX. So that's where I was like, I got to get to SpaceX. So went to University of Washington, majored in aerospace engineering. That's where I met my co-founder, Tyler Pierce. And through some internships, at Aerojet Rocketdyne, working in some of the labs on campus in the fusion department, I got to SpaceX and was there for 9 years as a propulsion dynamicist was my role. Biased opinion, the most interesting role at the company. There was only a few of us, and we were kind of the team that when things blew up, you would call us to help piece the data together to figure out what happened and how to prevent it from happening again. So really got to work with a lot of different teams and kind of from a bigger picture, but also getting down into the nitty-gritty technical details of things. So it was a great time. And the thing I love the most is it's hardcore. And at Turion, that is the top principle, hardcore engineering. Turion really started when I was at SpaceX, looking at always kind of having the itch. Even though I was at my dream job, I always had the itch with bringing the cost of launch down so much. What's next? Working on things like solving orbital debris became really an important problem for us. So got my co-founders together. One thing led to another. We got into Y Combinator, and from there, it's been off to the races. And that was about 3 years ago. So yeah, and really one of the enablers for Turion, not just the obvious one is the lower cost launch from Falcon 9 reuse and all that, but just as important, maybe even more important, one of the other enablers for companies like us to even exist is actually AWS ground stations. Not having to own and operate our own ground stations saves a ton on logistics, CapEx, I mean, you name it. So it's really one of the other pieces to the puzzle that allows a company like us to actually execute our mission. Besides that, on the AWS note, since we're talking about it, all of our cloud infrastructure and what we're building on from the mission control system to the mission planning and the user-facing APIs and applications, all of that is hosted on AWS Cloud. So we are hardcore users, I would say.
As you said, those pieces of the puzzle are really coming together. The place where we are in time in space exploration, where technology and cloud is right now, enabling companies like yours to really to accelerate so quickly. And as you mentioned, like that, the existential issue that is orbital debris. I mean, that is such a huge problem. I feel like this is a good opportunity for us to take a look at what Turion is doing. So I'd love for you to tell me more about the company. Give me a pitch and tell me about the cool stuff you're working on.
Absolutely. That's my favorite part. With Turion, what we believe is the space industry is only a fraction of what it must become. And with our goal of unleashing the potential of Earth orbit, we're going to build products and services to address some of the key bottlenecks. And, the first one that I mentioned, orbital debris, obviously is critical to the sustainability of the future of Earth orbit and a healthy commercial space economy. Without that in place, if there's no viable commercial space industry, space technology advancement will stagnate and we'll be waiting around for some rock to take us out. So we don't want that. That was really how we started the company and what we're focused on. But with orbital debris, it's a questionable market as far as it currently exists now, and the regulatory environment is still kind of uncertain and unclear. But with actually doing things like orbital debris, there's another piece to the puzzle that you actually need to figure out, and that's just looking at space objects, doing non-Earth imaging. So really what our more near-term focus on is helping address some of the key national security threats and gaps in the space industry and doing space-based non-Earth imaging, taking pictures of other satellites and doing things like rendezvous and proximity operations and space situational awareness. And when I say like flyby imaging and non-Earth imaging, like this isn't just like a point of light that you can do from ground-based optical systems and radar, which does a really good job. In fact, those companies are partners to us, not folks we would compete with, but really like we get image and object and you could see features of that specific spacecraft. I think you could probably connect the dots on what that might mean from a national security perspective, but understanding what other people are doing is a necessity towards and a precursor to whatever comes next. And yeah, with our Droid 1 satellite, it was our first satellite. It's been in operation now for 1 year, and it took us some time, but we're fully operational doing non-Earth imaging missions now for our customers. So it's a really exciting time. And I will say, like, one thing we haven't announced publicly, so I'll just throw it in on this podcast, is we have successfully got our first non-Earth images. Some of those we plan to share, some of those we do not. So it's a really exciting time at Turion.
Congratulations. That's huge. That's really awesome. I'm imagining the incredible technical challenge of acquiring that kind of imagery. The motion of things involved, the distances, just being able to pinpoint. What a fascinating problem that must be to unravel. So like that's got to be fun and really, really challenging, but fun.
Absolutely. And like I said, one of the core principles of Turion is hardcore engineering, and that comes from the top. Tyler and I are very technical founders, I would say. Now we're also heavily involved in different parts of building out the strategy, near term, long term. So really exciting time. We just moved into a new facility where by 2027, we'll have scaled to the production line to be able to do 45 satellites a year. And we're building the next one right now.
That's incredible. You need to be focusing on those incredible technical challenges, not so much the infrastructure that's backing it up. Like it needs to be there, it needs to be secure, it needs to be solid, but that you don't want to also have to spend a lot more time than you need to focusing on that. So it sounds like that's also where AWS can kind of maybe alleviate some of that and just let you all focus on what you want to be doing.
Yeah, not having to build our own cloud infrastructure definitely is nice. So that's kind of like the core bottlenecks that we see to unleashing Earth orbit. Those are the obvious ones, I'll say. I think the least obvious one, and this kind of segues into another thing I would want to talk about, is one thing we've learned from Droid 1, like to our core, is the misalignment of incentives across the satellite industry. And specifically what I mean by that is, let's say you're a satellite maker and you give satellites to other companies. The biggest problem with that is in terms of having aligned incentives with your customers is if you deliver a satellite, even if your documentation, your ICD is perfect, they're still going to have 1,000 questions on how to actually operate it, because operating the satellite is so intimately tied to the flight software and the design of the satellite. So one other thing we are doing is also addressing that kind of bottleneck and that misaligned incentive structure. So another thing we're doing is also hosting payloads on our satellites. And we're doing this a little bit different than a lot of other companies because we can give, I think, the best deal in the industry on a dollar per capability perspective, because with spare capacity on the satellite from a volume and just from a operations perspective, we're going to fill it up with some of our other payloads and our partner company payloads. And because of that, we can really give a good deal on how much it actually costs to host the payload and get to orbit. And we'll manage all the day-to-day operations and just provide the most simple experience that you can imagine for controlling what your payload might be doing. Just a series of tasking APIs and user interfaces. So that is really a big one, I think, in the industry that took us a long time to really understand. And the reason why we decided to do it is because putting satellites up in space for doing non-Earth imaging, space domain awareness, and eventually debris removal is not necessarily super cheap. We're pretty vertically integrated, so our unit cost is really good, but that doesn't mean it's cheap. And so by hosting other people's payloads and putting our extra payloads on those satellites, this effectively, by putting more satellites up, we can accelerate the rate at which we're putting data collection nodes in orbit. And that's how we're really going to capture kind of this first S-curve in the story arc of Turion Space.
Wow. Okay, so I have to wonder about like the cybersecurity, how that is involved in all these operations, especially with hosted payloads now in the mix as well. That's got to be a major concern given what you all are working on.
Most definitely. So from the telemetry and the command and control stuff that's going up to the satellite, all of that is encrypted end to end. So it's definitely something that we take seriously. In fact, A recent White House national security cyber paper that was published from the White House talks about cyber and a pretty good section about the space industry and what can be done to increase security. And one of those things, like one of the main tenets of that, which we agree with, is memory safe software development. So using languages like Rust that are memory safe inherently is one of the medium kind of term initiatives that we are executing so that we really have the best when it comes not only to just the satellite itself, but also from a cybersecurity perspective. And, would be great to just announce kind of like some of those products that people can go out and look. By the time this podcast is released, if you check out our website, you can take a look at what your options are for hosting payloads. And we're announcing our Droid Alpha family of vehicles, Droid Alpha Mini, Droid Alpha, and then Droid Alpha Enhanced Mobility. So another thing that we're going to be a little bit different from some other providers out there is we are not going to be configurable and have 20 options for every satellite. You're going to have those 3 options, and that's what we're building. Use it or don't. That means we may walk away from deals, but that's okay because that's not the primary business. We just want to host some payloads to accelerate the rate at which we put these up and build really strong customer relationships with a handful of people rather than everyone. So Droid Alpha Mini, that one's flying here pretty soon on Droid 2. And that is like the same vehicle bus architecture across our series of Droid Alphas. So Droid Alpha is up to 300 kg satellite, and Droid Alpha Enhanced Mobility is a little bit bigger, and it has our propulsion system integrated. Our propulsion system is a gridded ion thruster, which is counter to the mainstream, I would say, narrative when it comes to electric propulsion, which has really gone with Hall thrusters. And there's been some arguments why Hall thrusters are more preferable. Gridded ion thrusters are more complex. They can be far more efficient from a fuel efficiency and ISP perspective. But Hall effect thrusters are simpler and have higher thrust to power. So with electric propulsion, you're talking tens to hundreds of millinewtons of thrust. It's really low thrust, but it's really efficient. So Hall thrusters typically have like twice the thrust to power. But with some breakthrough technologies we're incorporating, we've actually addressed that with this gridded ion thruster architecture, and we'll be at comparable thrust to power. So the propulsion system is something we're stoked about, and we'll be integrating onto our Droid Enhanced Mobility vehicle. So those 3 vehicles, flight ready in 12 months, 18 months, and 24 months respectively. Give us a call if you want to fly.
Fantastic. And it sounds like secure by design as well, which is always great to hear. So you've touched on so many incredible things that you all are working on right now, things that are in the near term. What is your company's long-term vision?
Our long-term vision is really to solve orbital debris and build a multi-billion-dollar company in the process. But the long-term vision of Turion Space is to go extend beyond just Earth orbit and really unleash the potential and unleash mankind's galactic destiny. And what does that actually mean? How do we become a galactic civilization? I think it really needs to be economically driven. And what we are making a bet on is that platinum group metal asteroid mining is going to be that thing. We're going to learn a lot from some of the NASA missions going on right now, like Psyche, but platinum group metals from asteroids is a potential $1 trillion industry if it can be done. But what we also believe to our core is that it is going to take a lot of time, and it is going to take billions of dollars to actually do at scale. And without doing it at scale, it's kind of a moot point. So our strategy is to build the technical and the financial foundation, solving critical bottlenecks in the current Earth orbit industry, and use that as the catalyst for being the company that's going to be most well-positioned to go after platinum group metal asteroid mining. So that is the long-term vision of Turion.